So good afternoon. First of all, I would like to be grateful to the organization for inviting me to be here. I am Dr. Antonio Turiel. I am a senior researcher at the Institute of Marine Sciences of Barcelona, which, as Michael has said, belongs to CSIC. CSIC is the High Council for Scientific Research in Spain. And my main line of work is about ocean climate. Ocean climate mainly using satellites. So I work a lot with the European Space Agency. I work a lot in developing algorithms to process data. Work a lot trying to understand the physical changes that our oceans are experiencing right now. So very connected for sure with climate change and also with short-term changes and other processes and so on. And since some 20 years ago, I was also enduring, I would say, a line of work related to natural resources. So I started this just as a dissemination activity, and well, as time has progressed, I start to make also a bit of research. So I talk a lot about energy, I talk a lot about oil in particular, and well, that's the reason why I'm here. So I would like to explain you what is happening right now. So what is happening is something that in fact we knew that it was to happen more or less in the years it is happening. Why we're in the middle of energy crisis beyond the problem that we have in Ukraine. That of course it has a lot of influence with the current predicament. But going further, my idea will be trying to make a presentation of about 45 minutes, 1 hour, to give you the opportunity to make questions. I hope you may have a lot of questions. Also because this presentation, I think, is quite provocative. And one of the things that I would like to provoke in you is these questions, no? And the idea of trying to discuss things that I'm pretty sure that probably you would like to know. So the first thing to understand is that we are now entering the area which is called the end of cheap oil. So we have lived for a lot of decades based on not very expensive oil, even cheap oil, I would say. But in the last 10 years, there has been mystic changes in the oil market and in general in the situation of natural resources. What we have seen is that from 1993 to 2014, the amount of money that oil and gas companies spent in the search exploitation of new fields of oil and gas, what is normally called upstream, it was multiplied by 3 in this period of time, in these 21 years. But from 2004 onwards, it has been decreased by 60%. As you can see, it's not a constant decrease, it has some ups and downs, but it has been decreased by approximately 60%. And this is strange, taking into account that the amount of oil that we have now, the typical fields that we're exploiting right now, are typically concentrated on oil categories that are harder to exploit, maybe they're deeper, they need more processing because we're exploiting different things. And just to keep constant, we will need to increase a little with time. And instead of even increasing a little just to keep constant, what we have done is to decrease the investment. And the question is why? Why oil companies and gas companies has decreased the effort that they're doing in order to put more oil and gas? So the actual reason, now they say, oh, this is because of all these green regulations. This is false. This is not the truth. And in 2014, when they started, they recognized that the problem was a fiscal problem. And this is quite easy to understand when you look to this graphic from the Energy Information Administration, which is part from the US Energy Department. And what you can see here, the green line are the cash, the income from the 127 greatest oil and gas companies in the world, counting all of types, so public, private, multinational, or national. So the green line are their income, the amount of money that they were earning. And the blue line is the expenditure by the same companies. As you can see, consistently from middle 2011 up to 2014, the time at which this report was issued, there is a consistent, there are consistent losses of about $110 billion per year. So it's a huge amount of money, huge amount. This is the time at which fracking was ramping up in the United States. It's the time at which we were exploiting also tar sands in Canada, extracting the oil in Venezuela, and so on. And the fact is that they were losing money. They were losing a lot of money. And the key point here is that this happens at the same time that the barrel of oil was at the highest average price in all the historical series, even taking into account inflation. So I am not talking about the spike in price. We have a spike in price in 2008 that was larger than that because it was around $147 per barrel. But in this period going from 2011 to 2014, what we have is the average. If you take the sliding window average for the window of a year, this is the time at which it was around $110, which was very high. And significant enough, every time that the barrel of oil was beyond $120, very rapidly the price was reduced, which is a bit absurd if you take into account the losses that those companies have. And the reason why they were doing this is because there were several studies, and in particular, I typically quote about Professor James Hamilton's work on oil prices in the case of the United States, that said that there was a maximum price that the economy as a whole can resist. And in dollars of this period, it will be equivalent to $120 per barrel. And this is the reason why they were all the time trying to avoid being a lot of time above 120 because they knew that this will force recession for sure. So the question is that they were keeping the barrel of oil at the highest price that our economy can tolerate, and even so, they were losing money at a rate of $110 billion per year. So of course, this is not sustainable. This is something that could not keep pace. So for sure, this is the reason why they decide to decrease the investment and concentrate in the parts of the business that were still profitable. Just to be clear, they have reduced 60% the investment in the search and put in exploitation of new fields. It doesn't mean that they are not still searching for new fields, but they are searching much less than before. And take into account that in the last 20 years, the amount of oil that is discovered every year is equivalent to 5 billion barrels every year. 5 new billion barrels per year are discovered, but we are spending about 36 billion. So the question is that we're spending 7 times more every year than what is discovered. So for sure, this is not tenable. This is something that is not going to be maintained for very long, and this is what is happening actually right now. This is something that has been very hard to accept by the International Energy Agency. The International Energy Agency is a body from the Organization for the Economic Cooperation and Development, or OECD. And they are charged in giving advice to the governments of the richest countries, the ones belonging to OECD, in terms of energy. So they take the economic models from OECD and they try to interpret how the market of the energy is going to evolve to cover the necessities associated to the economic growth that is prescribed by those models. And since some years ago, they're running into troubles because it's very hard to encompass both things. The economic models are given externally and the realities of what's happening with oil. The first year that we saw that there was some problem here, it was in 2010 when they issued the World Energy Outlook, the annual report from the International Energy Agency. They recognized for the first time that the peak of crude oil, the conventional crude oil production, was in 2006. Well, in fact, it was in 2005, because in 2005 and 2006, it was exactly the same value. And if you look at this graph, which is taken from that report, what is crude oil, crude conventional oil, is this substance that is extracted on the wells, as the ones that you can see in the background of this slide, these typical wells that you have seen a lot of times on the films, which are pumping, going up and down. the typical Duncan head wells. So crude oil in that graph represents the three bluish fringes. So we have the darker blue, which corresponds to the oil coming from fields that were in operation in 2010. We have the grayish blue slice that corresponds to oil coming from fields that were already known but not still put into operation, and the cyan blue fringe, which corresponds to oil coming from fields still to be discovered. This is normal because you are discovering fields. This is a forecast for 25 years, so this is normal that they're including this. But the question is that in order to have this amount, they should have been discovering oils by amount 4 times the actual discoveries in the previous 20 years. But anyway, we are going to accept. And even with that, what we had is that the production of conventional oil was going to be stagnant for the next 25 years in a value of around 69 million barrels per day. Okay, so in 2005, 2006, it was 70 million barrels per day, and it will be, for that time on, 69 million barrels per day. But the message was, well, don't worry, because we're including the natural gas liquids, which is a bit tricky because this thing is mainly a mixture of gases that is useful for producing plastics at the refineries, but it's not actual fuel. And the other thing is the unconventional oil that is in that year was mainly tar sands from Canada and biofuels. Okay, and with those we could still increase a little. This is what they said in 2010. We make a fast forward to 2018, so we have already 4 years in a row in which the investment was decreasing, and we have a completely different forecast. What we have here is the 2 lines that you can see, the blue and the green line corresponds to the 2 basic scenarios contemplated by the International Energy Agency, and the new policies and the sustainable development scenario. The reference one is the one corresponding to new policies, so the blue line. And they put 2 things that are not the scenarios, actually. They are not demand scenarios, but are rather the possibilities for producing oil. This, let's say, darker red part, which corresponds to what they call the natural decline, is the way at which the production of oil decay along the years, taking into account the observed rate of decay of very mature oil fields that we have. And the observed decline is the amount of decline that you obtain, taking into account that you put the minimum investment to keep the oil running, you often do all the maintenance and so on. So even accounting for the observed decline, which means you're still investing at least in having a good maintenance of the oil wells, you will have a gap of around 34 million barrels per day over a scenario at which you were thinking that the demand were going to be around 100 million barrels per day. So this means a default of 34%. 34% is huge. It is enormous. I think it's very hard to overstate how huge this gap is. It's not only 1/3 of all the foreseen demand. Taking into account that during the 2008 crisis, oil consumption fell by 4 million barrels. In order to observe something similar to this 34% of descent, we should go back to the Second World War, at which the oil consumption fell by 20%. And here we're talking about 34%. So for sure, they were warning that we could have several price spikes ahead, as in fact we're experiencing right now. Okay, let's go to 2020. This graph is very similar to the previous one, but here instead of projecting only to 2025, they are projecting up to 2040. And something also interesting is that they have taken some tracers. They have a tracer, a marker in blue, a marker in green, and they have filled all the gap. But it's absurd because it's the same thing as here. I mean, this is not something that is going to be covered. You have 2 demand scenarios and you have 2 offer scenarios, and they don't match. This is what happens, they don't match. So it depends, of course. They don't know how much is going to be invested. If you could increase enormously the amount of investment in oil fields, you could try to fill those gaps. But this is not what is happening. This is not what is happening right now. Okay? So according to this forecast, what we see is that by year 2025, 3 years from now, in the worst case scenario that will correspond to the lowest part of the graph, this lighter brown part, so there will be a default, there will be a lack of about 50% of the oil to be consumed. And only in the case that you are at least maintaining the wells, in the case that you are making all the maintenance routines and so on, this gap will be reduced to only 20%, which is a lot, which is actually a lot. And well, the question is that this implies that we can have problems. We're starting to have problems actually from that point to 2025. The last report, that is on a report, is the World Energy Outlook from 2021, is this one in which they have taken another marker, the green marker, and they have perfectly overlapped it with the part corresponding to this maintenance of the wells, the investment to maintain the wells, and they call this new scenario net zero in 2050, excuse me. That will imply that we will go and make a very fast, very huge transformation of the society to put an incredible, huge amount of renewable sources so we can compensate by the fall of oil, but because take into account that for the for the International Energy Agency, they do not consider that there is a peak in the offer. There is not a peak in supply. There is a peak always in demand. They consider that society is not consuming oil because we don't want to. So they always considering this, and they, well, okay, we are going to create this new scenario in which we are going to ramp up at an incredible pace the amount of renewables we are going to use. Take into account that this scenario to be true, this would imply that lithium production, annual lithium production should be multiplied by 120 with respect to current values. You need to multiply it by 120. It's not an increase of 120%, no. Multiply it by 120. Or the nickel and cobalt production to be multiplied by 42. This is completely absurd. This is something that is not going to happen. Also because we have not enough reserves, but we cannot produce these materials at that critical, at a very fast rate. Interestingly enough, in this year, we have also a similar graph for natural gas, showing that we have not yet arrived to the maximum production, to the peak of natural gas, but it is expected to happen before 2030, something that people like me that we have been following this for years knew that this is exactly what is going to happen, that the production of the global production of natural gas is going to peak somewhere before 2030. The current situation is this one. This is a graph for the last years. So we see that the peak in oil production was, as more or less implied in the previous graphs, in November 2018. In this graph, we are not including the natural gas liquids because, in fact, this is not fuel. It's useful to make plastics, but it's not fuel. And the maximum amount, the maximum rate of extraction of oil or some things that can be consumed like fuels is 84.5%, 84.5 million barrels per day. And as of March of this year, the production was recovering before the lockdown in 2020 was about 80.4. The problem is that we are not able to pass this mark. In fact, all the trends are that we are going to decrease from that mark. So this is not ramping more anymore. In fact, OPEC is unable to ramp up production. In May, they promised to increase oil production by 400,000 barrels per day. In fact, they decreased the production by 50,000. So we are really touching the ceiling. We are not able to produce more. The United States is also at maximum rate. OPEC is a maximum rate. We cannot increase. I don't know, you have seen this video footage of the French President Emmanuel Macron talking to the President of the United States, saying, I was discussing the other day with the leader of the United Arab Emirates, and he told me that they cannot increase the production, and the Saudis are saying the same thing, they cannot increase the production. This is the point at which we are right now. So oil production is not going to be increased. This is bad for sure, but what is even worse is that diesel is collapsing faster. And diesel is collapsing faster because we need specific mixtures of hydrocarbon, liquid hydrocarbons, in order to produce diesel. And we have not adapted the refineries for the kind of mixes that we have right now, because we are increasing a lot, for instance, the oil coming from fracking, but oil coming from fracking is not so appropriate for producing diesel. And also the other non-conventional oils are not also as appropriate. This is something that, in fact, I was tracking since 2012 because I knew this thing was going to happen. Yes, it's a problem of chemistry. It's not, it's not more complicated than that. And this, what you can see in the graph is the blue line is the monthly reports of diesel production of the world, and the red line is the sliding window average over a year. And what you can see is that, well, that we were ramping quite fast up to 2005. We touched this moment at which crude conventional oil is not able to ramp anymore. It becomes a standard, and then it starts to decrease. So we went at a slightly slower pace. We have the crisis in 2008. Then we start recovering. The production of diesel start recovering, but not increasing as fast as in the previous years. And in 2015, it touches the maximum, it touches the ceiling. It oscillates. This bumpy plateau is typical of any commodity that is reaching to this maximum production. It starts to oscillate. And from 2018, it starts to decline. It declined during 2019. It declines for sure 2020. We have the pandemics. It continued to decrease during 2021. And now it has decreased by 15%. We have a very serious diesel crisis all over the world. And if you are taking notice, if you are paying attention to international news agencies, we have reports every other day about countries having problems with the supply of diesel. And this was affecting Pakistan, it was affecting Sri Lanka, that is more or less a collapsed country, it's affecting Laos, but it's affecting also Nigeria, which is a producer, it's affecting South Africa, it's affecting half of the countries in South America, and today it is affecting Austria. Austria is having problems to get the supply of diesel, as of today. But of course connected with the war in Ukraine and so on, but it's something which is quite worldwide spread, and as I said, this has not started in February this year, as the war in Ukraine. It started in 2018. The situation is not better when we look at the rest of commodities, I mean the non-renewable sources of energy. This is what happened with coal. This is what I'm presenting here is from the World Energy Outlook from the International Energy Agency in 2014, and it was the forecast they have for the production of coal in the next years. So they forecasted in 2013 that the production was going to be like that. So the production from existing mines was going to decline relatively rapidly, then very sharply from 2025 onwards. And this could be compensated a little what they call brownfield mines, which corresponds to the project for extending existing mines, so improving, making more galleries, better extracting methods, and so on. And the only possibility to really increase the amount of coal being produced will be by means of what they call greenfield mines. And a greenfield mine is what the name indicates. It's a mine in which you go there and there is a green field, and you can see goats and sheep eating the grass and so on. There is nothing there. So they say, well, below the surface you have a lot of coal, but for the time being you have nothing. So another way to refer to this, wishful thinking. For sure they have prospection, they don't even have coal, but until you don't make the first hole, you are not sure about how much coal is going to be going out from that place. This is what the forecast they have made, as I said, in 2014. What has happened? What has happened is this thing. This is actual data at the year 2020, and you can observe that the pressure was increasing up to 2014, and then it starts this typical bumpy plateau of really attaining the limits. So what happens when you are attaining the limits of the production of a commodity is what I call the effect of fly against the ceiling. No? You have a glass ceiling, you have a fly, and it is bumping against the ceiling, bam, bam, bam. So you have this bumpy plateau, which is an indication that it is at maximum extraction rate. As of now, the maximum rate has been in 2019. Maybe this peak is going to be more or less reached in a later year. I don't think so, because the lack of diesel is also affecting the extraction of coal. But well, this is the situation. This is not ramping at all. But the situation is much worse in the case of uranium. This is the forecast also extracted from the World Energy Outlook from the International Energy Agency 2014. This is strange because they tend not to put many forecasts regarding uranium. And this is what they expected for the extraction of uranium in the next years. So, as you can see, the blue is, the dark blue part corresponds to the production from existing mines. The green part corresponds to what they call secondary supplies. The secondary supplies correspond to the uranium that was extracted in previous decades, which is typically stored in the shape of atomic weapons. And when they dismantle atomic weapons, they are taking profit of it and putting this as nuclear fuel, which is not bad. And then we have this orange part, which corresponds to the production from identified mines. This production from identified mines is the same thing as the greenfield mines of before. I mean, there is no hole, they have not started works, nothing. So this is a part which has a lot of wishful thinking. And thanks to it, they were supposing that the production, the extraction from uranium mines could be increased up to year 2025, but then onwards, the production will be decreasing. And as the demand that is given by the scenarios by the OECD was expected to be increasing from 2025, you have the demand which is increasing, you have the production which is decreasing, you have a red marker, you take a red marker, you put a lot of diagonal strips, and you put supply gap. And we don't know how we are going to cover this. Maybe the Martians are going to arrive and bring us some uranium, we don't know. But this is in the official World Energy Outlook. I'm not inventing anything. This is the actual graph on there. Absolutely ridiculous. As it is the way it was presented. And this was in 2014. Now we can compare and see what has happened. And what has happened is this thing. This is the actual uranium production up to past year. This is from data taken from the World Nuclear Association webpage. As you can see, we touch the maximum. You observe again this bumpy structure typically of being close to the maximum. We arrived at the maximum rate of extraction, a bit above 63,000 natural uranium tons that year. And from that time on, the production has decreased and staggering 24%. For me, it's a bit ridiculous to talk about the future for nuclear. I don't know which uranium is going to be used. Take into account also here that the production is not increasing faster, thanks to Kazakhstan, that now it's 46% of the total production of uranium of the world. And this is not a very stable country, actually. In fact, if you remember, it was supported by Russian troops by the end of past year. So, well, the situation is, I would say, quite dark. So just to make a summary of what happens with renewable energy sources, we have that the production of conventional crude oil was in 2005. This was the maximum rate of extraction. If we can take into account also the non-conventional oils, not all of them very useful for producing diesel, for instance, it was in 2018, so anyway, it's already passed. It represented 33.6% of the primary energy consumed by the world. Regarding coal, the peak of coal production was in 2019, and it represented 27.2% of primary energy. Natural gas, we expect it to arrive to maximum extraction rate in this decade, probably in the same period of 5 years. It represented 23.9% of primary energy. And regarding uranium, the maximum was in 2016, and it represented 4.4% of the primary energy. If you take into account all the sources of non-renewable energy, the maximum rate of extraction, the peak non-renewable energy, was at some year between 2018 and 2020, anyway, a year in the past. And they represented 89% of all primary energy consumed in the world. Something that I would like to let you clear, I mean, I think it's clear from the graphs, but it's something that maybe needs to be clarified. We are talking about the moment at which the rate of extraction of energy of the material is the maximum one. So this is time of the history in which it was maximum. From that point on, the amount of extraction is going to be decreased. This is not to decrease fast, or it's not required to decrease fast. So in principle, it's supposed to be decreasing slowly. In the case of oil, taking into account all the divestment, probably it's going to decrease a bit faster these first years, but then I expect to have it decreasing in a slower pace. So the situation probably is going to be prolongated for years and even to decades to come. Okay. The question with attaining the maximum rate of extraction of non-renewable sources is that from that point on, you are having less energy every year. The situation, I always compare this situation to that of one person that has a salary. The salary of this person is decreased by, let's say, 2% every year. So this person is earning his money or her money, but every year is earning less and less and less money. So life is becoming tougher for this person. The things are harder for this person as time passes. Well, this is our situation. We're going to have less and less and less energy available as a whole, as a world. It doesn't imply that it's going to be shared homogeneously or even fairly all around the world. There are some countries that are going to keep a larger share of this and others which are going to decrease faster because of that. But this is anyway our predicament right now. So, sorry for the mistake. Are renewable sources the solution? Well, it is obvious that in the long term, all energy will be 100% renewable. This is nothing to discuss here. Anyway, we needed to do this to fight against the climate crisis. And it is clear that also taking into account that you have this geological decrease of the production of renewable resources, that we are going to have this 100% at some time in the next decades. We don't know exactly when, but this is going to happen for sure. But having 100% of renewable energy doesn't imply that this is going to be the same amount of energy that we have today. This cannot be taken by granted. So everything is going to be renewable, but it's not necessary to be the same amount of energy that we are having today. Because renewable systems have many limitations that are rarely discussed. First, they have a maximum potential of energy that can be extracted from them. They depend on scarce materials, they depend on fossil fuels, and there are also some inconveniences associated to the fact that they are oriented to the production of electricity. Regarding maximum potential, I'm not going to enter into the details because this will be a very lengthy and complex discussion. Let's say that from the time being now, people accept that the maximum amount of energy that can be extracted from renewable sources will be around 4 times the present consumption of all sources of energy, which is a lot. But anyway, it's a finite amount, so this cannot be increased, the consumption could not be increased forever. But there are some authors, in which I include myself, that we think that most likely the amount of energy that we can extract from renewable sources is around 40% of the current consumption of all sources of energy, which is still a very large amount. I mean, it's a large amount, large enough to allow to life with life standards, because taking into account that a lot of energy today is wasted, because it has an economical sense to waste it. So really, probably we don't need to consume as much energy as we are consuming right now, especially in the most developed countries. Okay. Anyway, this is still something which is open for the scientific controversy. We don't know yet if it is 4 times the amount of energy we are consuming, just 30–40% we are consuming right now. But anyway, it's a finite amount, so this means that the consumption of energy cannot be increased forever. But there is another more critical issue which regards the use of critical materials. I always quote this work by Alicia Valero, who is a professor at the University of Zaragoza, and she, with her collaborators, are working in what we call industrial ecology. And they have identified that the non-reserves, even counting with the proven reserves of several materials, are not enough for allowing all the planet to make the transition at the same time. And you have here a list of some materials. We have, for instance, silver that is used for the connectors in photovoltaic systems. We have lithium nickel, manganese, cobalt, which are necessary for batteries. We have tellurium that is also used for the photovoltaics, and also copper. There's not enough copper in the world in order to allow the complete electrification of everything. This thing is more or less recognized by the International European Agency, International Energy Agency. I'm sorry, because I am so used to say European Space Agency, they are all the time putting European somewhere. So I see an E and I say European. No, not in the International Energy Agency. So in a report that they issued past year in May, which was called Critical Materials, in fact, and they said that, well, the amount of the productions of these materials should be increased by really huge amounts. It was even worse in the annual report, but here they were talking about multiplying lithium by 42. In fact, in the report, in our report, say 120. So, well, you know, you put an Excel, you put to calculate, and you obtain a number. This does not mean that this number makes sense. But something which is interesting is that at the end of the report, they gave 6 recommendations, and one of them is that they recommended the countries, the OECD countries, to the creation of strategic stockpiles, which is a way to say hoarding. So to acaparar. No? So you hoard the materials thinking that, well, maybe there is not enough for all the world, but at least try to guarantee that you are going to have what you need. The other problem that we have with renewable systems is that they're strongly depending on fossil fuels. As of today, nobody has ever installed, extracted the materials required, transformed them in a factory, transported them around, installing these systems, maintaining these systems, and eventually dismantling these systems without using fossil fuels or using only renewable energy. In the construction of all those systems, you are implying huge amounts of fossil fuels. For sure, the carbon footprint is smaller than one of a natural gas plant, but it doesn't imply that there is no consumption of fossil fuels. And now that fossil fuels are scarce, this implies that they have problems because everything is becoming more expensive. And something which is critical is that we don't know if we could just install these systems if fossil fuels are not around, especially for the part that has to do with the extraction of the materials, with the deployment. The third problem, or the fourth problem I would like to mention about these systems is that these systems are related to the generation of electricity, which has 2 problems in the context of the world, and particularly in developed countries. All over the world, electricity is only 20% of all final energy. So from the waste we are using to consume energy, electricity only represents 20%. In countries like Spain, it arrives to 23.6% right now, and it's more or less the same in all developed countries. Another problem is that in many countries, and in Spain is not an exception, the consumption of electricity is not being increased very sharply. In fact, in Spain, it is decreasing since 2008. In Germany, well, it has increased a little, but it is mostly stagnant and very similar in other countries. So we are not seeing a huge increase of the amount of electricity we are consuming. And even if we think that it will be reasonable to attain a degree of electrification of society around 30, 40, maybe 50%, we know that there are many uses of energy that are very hard to electrify, very, very hard to electrify, even impossible to electrify. So it is not clear which is the advantage of installing as many systems for producing electricity when we don't know how to do with that much electricity. And this is one of the serious issues about this thing. Of course, we can think about batteries, but lithium is scarce, cobalt is scarce. We can think about green hydrogen. The last report by IPCC, the one we issued in April, they said, they have reviewed all literature, they say the green hydrogen technologies are not mature to be deployed in massive scale. In fact, they are very inefficient. You are losing a lot of energy when producing green hydrogen. And one of these losses is, well, some of these losses are going to be always there because it's a thermodynamic question at the end. So we have no silver bullet. We have no easy way to how to proceed in the way to electrification. I will also comment later a bit more on that. Now we're in the middle of a rising tide of crisis. I don't want to scare you more than probably we have already done. But let me just make a very fast review without entering into the details of the things that happen in the world right now. So as most of you probably know, there is a food crisis all over the world right now, owing to the high natural gas and diesel prices. Many countries have imposed bans on food exports, feeling that they could not feed their own population. So this has worsened the situation. Also, we have a war in Ukraine that is also worsening the situation. Diesel is now scarce in many countries. This is also affecting kerosene, because when you lack of diesel, you can add up a bit of kerosene. And this implies that we have problems to have jet fuel. For sure, the war in Ukraine is increasing the fuel and food scarcity. World Bank warning that we are going to run into a human catastrophe because of this, which is probably going to affect about 40% of all the world population this year. And, well, taking into account all together and all the problems with Russia and so on, a deep energy crisis now is unavoidable, especially in Europe. So the International Energy Agency is warning that we are going probably to have fuel shortages this summer in Europe. We'll start to see that, in fact. And not only that, the problem is that electric renewable systems are not going to save the day, in particular because they depend a lot on fossil fuels. The costs have a skyrocket, and now they have problems to earn money. Probably some of you know that Gamesa now is bankrupt. It's not going to be bailed out, but anyway, it has filed for bankruptcy, which is one of the big builders of wind power systems. But it's similar to Vestas or Nordex, for instance. They are not in bankruptcy. They have decreased a lot of profits, and they are closing factories. The problem is that at this moment, taking into account the problems that we have in all the supply chain all over the world, mostly associated to the problem with the diesel, with the transport, with also the cost of the transport on over the seas, well, it's difficult to make a profit of it. So the situation is very bad. So this is the bad part of the talk. I am going to the good one. Don't worry, it's going to be quite short. So the question is, after all the things I have explained, which is a very different point of view about the things that you have been told every day, what you are hearing at the news, but unfortunately it's something that, as time passes, confirms the thing I have been explaining over the years. So that doesn't mean that we can do nothing. The best thing that we can do is just lie down and expect the death to come. No. Nothing to do. It is the exact opposite of that. It's not that we cannot do anything. We can do a lot of things. In fact, we must do a lot of things, because there are lots of things to be done. Everything needs to be rethought, reframed, refurbished, redesigned. We need to do a lot of things, an incredible amount of things. And as I understand, the vast majority of you are engineers. In fact, this could be the golden age of engineering. This could be the golden age, because we need to do a lot of things. We need to rethink everything. We need to start from scratch. And I don't know, but in my case, I am a physicist. But sometimes when you are doing something, I say, okay, hey, wait. You throw away the paper and start from scratch. And sometimes this is exciting, because it's a fresh start. It's an opportunity of doing the things the right way for once. But for that, we need to make a lot of changes. And part of the changes are changes in the focus of our work, which are the kind of things that we should concentrate on. I'm going to discuss this a bit later. And also changes in our culture. We cannot have a culture of overconsumption, for instance. We need to focus on the real needs of humankind. We need to concentrate on the things that really need to be done. And we need to discard things that are not necessary to be done. We should be more focused, more clear about the things being done. And something that people don't like to discuss, because it sounds like a kind of obscenity or bad word, we need to question capitalism, because the reason why we have all those problems is because our economic system is oriented to grow. We need to grow. And this is absurd, because we live in a finite planet. We cannot have an ever-increasing oil consumption. We cannot have an ever-increasing lithium consumption. We need at some time stagnate. exactly the same as any living organism makes, exactly the same as any ecosystem makes in this planet. And we are living beings. We are in an ecosystem. Our ecosystem is similar to the one made by ants. There is a part fabricated by them, and it's a part which is natural. All of us, we need water, we need food, we need clean air, we need a lot of things. And at the end, any ecosystem needs to be in equilibrium in order to be stable, because otherwise, what happens, they enter in overshoot, which is our current predicament. We are on overshoot right now, and they can collapse, and ecosystems can disappear, and can be substituted by other ecosystems with different species. So it's not bad to say capitalism is unsustainable, because in fact, we all know how many years we have been discussing about climate change, and we have done nothing practical about that. We have done nothing. I mean, the CO2 emissions have been increasing all the years. The only 2 years in the last 30 years that the emissions of CO2 have not been kept at constant pace or even increasing has been in 2008 because of the economic crisis, and during the lockdown in 2020. The only 2 times at which CO2 emissions were not increasing. And taking into account the CO2 lasts for 100 years all this in the atmosphere. So it is accumulating, and degrading our living conditions. I don't know for the people coming from other countries, but here in Spain, we have suffered 2 heat waves during this spring, because it was a spring, it was not summer even. And we have a very bad forecast for the rest of the summer. And we have problems with gas, we have problems with many things. Well, I think that it's important to say capitalism, as it is conceived right now, is not sustainable. And I think it is not bad in saying that. You're not saying, okay, we need to tear it down. No. We need to make it evolve. We need to change it in a way that everything can be kept in equilibrium. We don't need to destroy the capitalism. We need to make it to evolve to something that is compatible with the planetary boundaries. The planetary boundaries that the people like me that we are working on environmental sciences are been discussing for a lot of years. I don't know if you know about the planetary boundaries. This was a concept that was defined some 15 years ago. A group of scientists identified 9 planetary boundaries regarding different things: climate change, biodiversity, water, and things like that. Contamination by chemicals, pollution by chemicals, and so on. Trespassing, going beyond any of the thresholds identified, would imply the existential threat for our species. And at this time, we have not gone beyond one threshold. We have gone beyond 5 of those thresholds. So I don't know what we are waiting for. We're waiting to going beyond the 9 of them. It's absurd. So we need a cultural change. We need to do the engineering of the future, which implies to construct a world in which we can live, we all can live. And this implies forgetting about this absurd, unsustainable idea, demential idea, I will even say suicide idea, of growing forever in a final planet. This is as simple as this. Adaptation to the new times implies the moral imperative of actually locally thinking globally. This is the key point of all that. It's said that Albert Einstein said once that those who have the privilege of knowing have the imperative of acting. And this is our predicament for us, I mean, for all of us, that the people that we are in this room. If we know that we need to do the things otherwise, we should do the things otherwise, because we know. And we should not be shy in explaining this. We should not be shy. No, we cannot do that way, because this is our condemnation. But we are not done to disappear. We are not done to collapse. We are not locusts. No, sometimes I explain, when I talk about the ecological crisis, and our species is a species that is in overshoot right now, because we are being very clever. We have taken a lot of profit of some resources, and we have grown over the current capacity of our ecosystem, of our habitat. And what happens to any living being that goes beyond the current capacity of its habitat is condemned to collapse. It's what happens, for instance, with marabunta, with the ants. They reproduce a lot, they destroy everything, they arrive to the sea and they die. Or with locusts, they start eating all the harvest, they arrive to the sea, they die. Or with algae bloom in the ocean. They have a lot of resources, they bloom a lot, they asphyxiate all the life around, and finally they collapse. So we are exactly in the same situation. I only hope that we are going to be cleverer than an insect or an unicellular organism, but well, this is still to be proven. Anyway, we need to think globally, and we need to act locally. And this is one of the things for people working in engineering has a lot of things to say. And at the same time, do not forget about climate change. It is still there, and there is planetary boundaries. And the fact that we are arriving to the maximum rates of extraction, the geological maximum rates of extraction, oil, gas, coal, and so on, doesn't imply that the problem of climate change is solved at all. Because we can go ahead and try to consume the dirtiest and more CO2 emitting sources of hydrocarbons. So we need really to stop on that. In fact, if we have ever taken seriously the predicament of climate change, we would have never noticed the problem with the geological exhaustion, because the need for decreasing the consumption of gas, oil, and so on will be faster. So in principle, we should not have observed that, because we should have started quitting them before that. Okay, so let's go for practical things. Yeah, just 2 slides. Well, as of today, these science have prioritized immediate economic return. So you are trying to do the things the cheaper taking into account the cost as of today of the different materials that you're using, the different parts you're using, and so on. But the problem with monetary value is it's a moving reference. Now we have a lot of inflation. What is this inflation that we have reflecting? It is reflecting that things are getting its actual value, the actual cost of doing things. They were enormously cheap because oil was not expensive. But now that oil is expensive and you cannot get some material in a mine, I don't know in which corner of the world, then transport to China to be processed, then to produce the product, and then bring it here. Now that oil is expensive, you realize how expensive was all the process. So the problem is that monetary values are not constant, and are not going to be constant anymore. The following years, what we are going to observe is not even expensive prices. We are going to see volatile prices. Sometimes things are going to be very expensive, sometimes they are going to be very cheap. Every time it is expensive, it's because you are hurting against the scarcity of oil and so on. Every time it is cheap, it's because one country is now on the shit. One country, or the economy of the world as a whole, is in serious crisis, and the demand has fallen. So we are going to observe these volatile prices, and this makes things very complicated. So monetary value is going to be a moving reference, especially in the first years. Not only that, the monetary value does not discount future scarcity, not for sure, and this we all know, environmental damage. So when we are going to assess the cost of everything that we are going to design, everything we are going to do, we should put the emphasis in societal value, not the current economical value. And calculating the societal value of anything that we do implies to compute the energy expenditure, taking into account that sometimes energy is going to be scarce. So we need to know exactly how much energy we are going to consume. The material expenditure, we need to know how many materials we are going to consume, everything. We need to also think about the recycling disposal cost, because this is also important. Recycling sometimes is very costly in terms of energy, in terms of other materials and so on. We need to compute that. We need to take this into account. The environmental impact, for sure. We cannot do things that are very environmentally impacting. And finally, for sure, the current and future economic return, because at the end it's an economic activity. So the economic value, the monetary value is going to be important. But this is just one of the items that should be considered. All the items should be considered. Also from the perspective of the economic return, because economic return is not going to be constant. And if you don't take all these things into account, sometimes maybe it's better to do something that currently is a bit more expensive, but it is going to have a price which is more assured. That making something that is going to be very cheap today and can be very expensive in, I don't know, 2 years from now. And something which is very important, and this is the actual meaning of sustainability. We can only afford something if our children can also afford it. Because this is the essential of sustainability. We should do the things in such a way that the generations to come could do exactly the same way. And if we're not doing so, this is not sustainable. Another important thing, energy as a tool, not as a goal. Energy is not what we want. In the discussions these days, there's a lot of focus. We need, I don't know how much energy. But this is false. We do not need energy. We need energy as a means to obtain what we really want. We want energy to obtain food. We want energy to have transportation. We want energy to obtain materials or to transform materials, to build things, whatever. But the energy is not the goal. It's just a tool. So instead of putting the effort as it is done today in producing more energy, trying to discover new magical energy sources capable for doing I don't know what, things that probably are thermodynamically forbidden, the focus should be put in what we need. And then think how we can do this, with which sources of energy, and if we can optimize, we can save energy in this process. Also, something which is very important, because it's also plugging the conversations of these days, is that we should not get diluted by the amounts of gigawatt hour that can be produced using one or another source. You are piling up on gigawatt hours, this can produce I don't know how many, because something which is critical with energy is that each specific use requires a specific type of energy. You cannot use electricity for instance, for doing steel. Even if they insist, you cannot. You can do metallurgics using electricity, but if you want to produce steel from raw materials for iron ore, you at the end need a source of carbon. You need other things, but you need a source of carbon. And this happens very similar with other things. So each use of energy implies a specific type. So when we are piling up as if everything was the same, different energy contributions, we are deluding ourselves. We are thinking that we are solving the problem and we are not solving it. We need to think about how this energy is going to be used, because as I have said at the beginning, energy is not what we want. And additionally, something which is very important because it also brings a lot of confusion, we should not confuse energy with exergy. So the sun sends a lot of energy to the Earth every year, which is around 10,000 times the amount of energy which is consumed by the humankind. Okay? But the problem is that how many of this energy is really useful, can be taking profit for doing unuseful work. And the problem is that it's not all of that. You have some source of energy which is very entropized, which is the case of the sun. You need to concentrate, and you are going to lose a lot of energy because you have entropy there. And probably you recall when you study this, you have the entropy, you have always this second law of the thermodynamics, annoying. So at the end, what we need, in fact, is exergy. We talk all the time talk about energy, but we need is exergy, which is the amount of energy that we can put to make useful work. And in order to account for exergy, we need to account also for the system making the transformation, because this is not, this is not a state variable. This is a process variable. So it depends on the specific path that you follow in order to obtain this useful work. So taking this into account, it's not only the amount of energy you can obtain, it's also how we are going to put it to use, to make something useful with it. Regarding the use of materials, the way in which we use the materials is not neutral. Materials have energy and environmental footprints that need to be taken into consideration when you are discussing anything. You need to have this into account. You need to compute it. It's very important. As we already know, recycling rates are very low today. We have some specific cases, as for instance lead, for which we have a very large amount of recycling right now. I don't remember, but it's the mark on 90%, I think. But for the vast majority of metals, for the vast majority of materials, we are well below 20% of recycling. It's very, 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 very low, actually. And the main problem in recycling, in the majority of cases, not all of them, but in many cases, is due to the energy intensity that is required for recycling. Recycling is many times a costly process, something that requires a lot of energy, and precisely we have a problem with energy. So the best way to recycle is to start by the beginning, in the design. When you are designing the thing, you should be thinking about how you are going to recycle things, the parts that are included there. Also, we need to think about the end of lifetime. We should think about, for instance, the potential impacts of abandoned systems, abandoned objects, because we abandon things in the middle of the environment. This is the kind of thing we do. If you're using plastic bags, think what is going to happen when these bags end on the sea, for instance. So we need to take this into account. When designing everything, we need to know what happens when you do what you should not do. But this is very important. We need to take this into account. Also, another problem that is very common now, especially regarding the TICs, it's not said like this in English, is the information and communication technology, ICTs, is that in many cases we're using materials that are entering in trace concentrations, so in concentrations which are very low. And this is very dangerous because this typically implies the impossibility of recycling, or that the process of recycling is going to be to emit a lot of toxic waste and things like that. So when we're using these things, we need to think a lot and trying to think if we can use these materials that are entering in these small amounts. And also a consideration which is important. I mean, it's very good that we have a knowledge of the whole periodic table of the elements, but take into account that you are going, for instance, for rare earths or other low concentration materials that are concentrated very slightly on mineral ores. Something that is in trace amounts of mineral ores are always going to imply a lot of energy and, even worse than that, a lot of waste and environmental impact when they are extracted. And I don't know if you know, for instance, how rare earths in general produced in the world, but many of them are produced by leaching and other very damaging environmental practices. So it should be taken, also this should be taken into account. And when you're using this, you should not be prodigal on their use. You use this very rationally, because otherwise you are increasing the impact on the world. To end with it, programmed obsolescence is not acceptable. In a world with scarce resources and even more and more scarce as time passes, we cannot accept something like that. We need to do the things in a way that the lifetime is as long as possible, they are as durable as possible. Also, taking into account that this should be compatible with the fact that we don't want to pollute the environment, so they should also degrade in some sense. Something that we also need to think about is to use energy beyond electricity. There are other ways to take profit of energy, and many of them were very well known by the beginning of the 20th century. We should put all the knowledge that we have by the beginning of the 21st century and put up to date these things in order to take profit of them, to use them in factories, to use them for metallurgy, to use them to produce chemicals, to produce a lot of things, using all the knowledge and technology that we have today, and not always producing electricity, because sometimes electricity is not as interesting as it. Because these systems typically have less impact, they are more efficient and so on, but the problem is that they are following the natural process of the Earth. They are following the natural cycles of the Earth. They are not in favor of the dynamics of accumulation, which is typical to capitalism, but anyway, they were practical enough, and they were good enough, and probably they should also be considered when we're talking about the transition, but unfortunately, this is the kind of thing that is scarcely discussed. So the conclusions, I'm sure, because I have extended more than I wanted. Well, this is also true that we start a bit later. We're in the first stages of the post-fossil fuels uranium area. This is creating a serious problem of material scarcity. The model of energy transition that so far we have fostered during the last years simply won't work. It is not working. And we have the companies dedicated to the production of systems of photovoltaics and the wind power systems are struggling right now. But it's normal also because, well, we knew that they have unsurmountable technical hurdles. But this is not the end of it. It is the beginning. We need to re-engineer the whole society to take all those things into account. The reason why we have led ourselves to this cul-de-sac is because we have an economic system that whose imperative is to grow forever in a finite planet. So if there are people that think that the Earth is flat because they think there's an infinite plane, are economists. But on contrary to that, the Earth is a sphere. It's a huge sphere. It's a really beautiful, marvelous planet, but it is finite. It is not infinite. So we need to stop with this craziness. We need to change the focus of our work and really put, not saying we are going to put or making greenwashing campaigns to say, oh, well, we are sustainable. No. We really need to put sustainability on the center of our work as a true and most durable economic objective, because also from the point of view of the economical profit, of the economical return, this is the best strategy in the long run. Everything is to be done, and everything can be done. Let's start. Thanks. So do you have some questions? Yeah, in fact, I think you're right. I mean, a big part of the problem that we have, I think it's more deep than that, but a big part of the problem that we have is really the tragedy of commons, because we have common resources, for instance, we have common environment that we're polluting, common resources that we are not paying for them, because when someone is extracting something, it is not paying for the resource, it's paying for the extraction cost. But the resource on itself, which belongs to all the humankind, he's not paying for it, okay? So this is really, yes, it's very well connected to the tragedy of commons. And you know that Elinor Ostrom was awarded the Nobel Prize in Economics precisely because of her work on the tragedy of commons and how it can be circumvented. And it's typically by use of common laws, common rules, so how the commons should be managed, because something which is common should be commonly managed, it is clear. This does not preclude, for instance, private property. It has nothing to do with communism, for instance, has nothing to do with that. It has to do in managing things that at the end are for all the people, because all the people need that. So in fact, it's like it's if you were signing a kind of contract with all the community for the exploitation of this, and also which is accounting for the externalities, because the main problem also is the externalities. Any economic activity for sure is going to be more profitable if some costs you are externalizing, so you put them to anyone else to pay for them. No? So in that sense, yes, I think that a way to circumvent this will be by putting practices that have been applied in many cases, for instance, fisheries. The management of fisheries in many places follows the scheme, and this is the way to avoid to exterminate fisheries in some places. And this is, I mean, it is operated by private companies. In fact, they make an agreement between them, among them, and they agree all together how to manage the common good, because otherwise they know, they are going to really exterminate it. So maybe this is the kind of thing. I mean, I'm not an economist, so I don't know exactly which will be the way. So I am mainly concentrating on the part regarding the technical part, because I think the technical part, we need to put this on the center, this is clear. And maybe the way to enforcing this is by the implementation of regulations, laws, I don't know. But the problem with laws, regulations is that they can very easily be perverted, especially if you don't change the economic system. As the economic system is oriented to the increase in profit, I think that you are going to run in the same problem once again. So I think that we need to change our focus as society. My overall impression is that there is some wider range in the society that is now most willing to accept this, especially in the productive areas. During the last months, I have been contacted, for instance, by people coming from enterprises, medium, and sometimes a bit large enterprises, but which are working in the productive system. They are producing something. And for one who produces something, they're really interested in knowing how to do this, in some sense, well, they don't say it like that, but sustainable. Especially in this environment in which, there are many uncertainties. Now we have a lot of problems with the supplies. There are still supplies that are not arriving. We have problems with materials that are not arriving, or they are more expensive, or, they have a lot of risk. And they want to know how we could do this in a way that we can continue on doing the things the same way. Because the people that produce something typically loves the thing they are doing. And typically they want to do the things in a way that they can go ahead doing this. And I think that we need to help them for doing this. The main problem for me is not in the people working in the productive system, because I think that we can arrive to an agreement. For me, the main problem is the financial sector. The financial sector is absolutely crazy right now. You know that the size of the financial economy is now 70 times the size of the productive economy, something like that. This is absolutely crazy. And I think this is the thing that is absolutely unsustainable right now. And this is the thing that probably needs to be really reformulated completely.
Maybe related to your answer to that question, maybe the point that what is clear is that the capitalist mode of production is the problem here. And as you said, maybe the productive sector is not so, maybe it's able to understand which is the problem actually, and the financial sector is the problematic point here. And this is the most challenging part of this story.
Yeah.
Because they are not going to very easily understand that this is the problem itself, the capitalism. So I think that if we want to be idealist, we can say, okay, we need to change the production system, but they are not going to agree with us, even with the productive system.
Yeah.
And then we can think of a lot of different worldwide problems that we need to face or suffer, maybe.
Well, the question is that if you go to a guy and you say, okay, you are the problem, probably this is not going to be well taken. So, but I tend to agree with what you have said. So I think that the essence of the problem is rather, the essence of the problem is also all of us, because our consumption, uses, habits, and so on are also part of the problem. There are many things that we are doing on our daily life basis that are also part of the problem, for sure. But for sure, the most problematic part is regarding the financial sector. And for that, I think that we need to offer them a honorable exit. And this is probably the worst part. This is probably the most difficult thing. But I have not the answer to that. What I say is that we need to know how, from the technical point of view, how to do for doing things more compatible. Because at the end, what we want is to do maybe it sounds a bit, selfish, but I think that we want to do is to go ahead and doing the same things we are doing now forever. We want to do the same things as we are doing now forever. And I think this is okay. I think this is logical. So we need to know how we can do these things in such a way that we can do them forever. And this is essentially the idea of sustainability. Doing the things in such a way that we can keep going, we, our children, the children of our children, and so on, forever. And this is the key point. For me, the financial sector as a whole, probably should be analyzed every part, but as a whole, I think it's completely, nowadays, generalizing, but maybe a bit too much, but I think that they are completely out of rails. They are completely out of this world. Well, if the financial economy is 70 times the productive economy, I think that we have a problem. And I don't know how to solve it.
The point is that if we agree that the capitalism is a problem, capitalism means basically the ruling idea is that there is a contradiction between capital and work, production. And then when you go to the people and tell them, okay, this cannot be done anymore, this
take into account that there are two different things. One is the property of the production means, the private property of the production means. The private property of the production means is not unsustainable on itself. What makes the system unsustainable is the fact that there is a tax, a rate of revenue of capital every year. So the compound interest at the end. This is what makes it unsustainable. The fact that we need to increase the GDP by 2.2% every year in order to have full employment and this kind of thing. So the fact that economy as a whole needs to be increased, and it's not in fact economy, it's this the economic flux what needs to be increased. So the economic output needs to increase. And this is what it makes it unsustainable. So of course the question about, for instance, the private property of the means of production, this is a political issue. This is, anyone can have a position on that. But this is not the roots of the unsustainability. And in fact, well, everyone can have I have my own opinion, for instance, about this, but I don't think this is the key point here. It's not the technical point in this discussion. The technical point is what is sustainable, what is not. And what is not is the need of increasing in a finite planet. This is what is sustainable. Yes?
Yeah, I wanted to point on the origin of this increasing of this growth. I don't think that we can expect an economic growth. I think what's unsustainable is the concept of profit. If we are expecting a global profit, everybody gets profit. Where that does come from, it needs to come from creating more money. That's the reason of the growth. If everyone here, if this is a market and everyone here comes out with some profit, where does that come from? Where does the money come from? If someone has profit, either some other one has losses, or there is an increase
of the monetary base. Yeah.
And this is unsustainable.
Yeah.
Money is unsustainable.
The way in which our monetary base, but in fact this is another way of putting the same thing. Yeah, I agree. So for instance, in a stationary economy, your profit is the other one's loss if the economy is stationary, but our economy is not stationary. So what is happening actually is that more money is being created at every time because the activity is increasing and increasing, but you know that money is being created. I mean, banks are emitting constantly money in the form, because money has different, this is quite a complex subject in fact. Money has different functions. This is a reserve of value, this is a token for exchange, for trade, and also it is debt. And when banks are creating money, they are creating as a debt. So I owe you, I'm going to give you something. And this is what forces, for instance, when you receive money from the bank for doing more activity in order to compensate the fact that the monetary base has been expanded. So yes, you're right, but at the end is another way of putting the same thing. So it is making us this necessity of ever increasing the production, ever increasing the consumption and so on, is because the monetary base expands, and the monetary base expands because banks are giving you money in the expectation that you're giving them more money. And either, if you are in a stationary situation, either you are losing or the activity needs to be increased. And this is what's happening. It's increasing up to we have arrived to the limits that we cannot increase any further.
But then you cannot expect economic return.
You cannot expect a net economic return, yeah, you're right. No, you cannot expect an economic growth. Take into account something. You, as a human, what do you need, actually? You need food, you need water, you need to have rest, you need clothes, you need a house, you need the love of the people you love. This is the kind of things that you actually need.
I don't need money.
You don't need money. You don't need money. Yeah. With money, it happens something similar to what happens with energy. We don't need energy, we need what we want to do with energy. We don't need money. We need the money to obtain the other things that we actually want. And many of the things that we actually want, we are not purchasing them with money. For instance, the love of the people that we love, we are not purchasing this with money. Well, with my children, I don't know, sometimes, but no, it's not true. But anyway, so the problem here is the same one. Yes, I absolutely agree. It's the same one. So we are living in a world which is structured on the sense of increasing profit and so on. But this is because capital needs to have this compound interest, this rate of increase. This is what forces us to increase activity. Anytime we are receiving money from the bank, we need to increase our activity just to be able to give them back what they have given. But they have created this from scratch, from thin air, really, like this. So the problem is that we are now hurting against the planetary boundaries.
But we do need energy. We don't need money, but we do need.
We need energy, but we don't.
And we need.
Well, money. No, this is not completely true because money, as a token of trade, is useful. I mean, it is useful
We don't
to.
need trade.
Well, we need trade because you are not going to produce everything you need. Well, you could do that, but probably it's more efficient if you are concentrating the things that you do the best, and other people concentrate on things that they do the best, and then you exchange, you trade. I mean, trading is something which is natural to the human being. I don't think that trading is bad on itself, which is.
I can give you. I don't need to trade. I can give you what I.
This is
what I
trading.
produce.
This is trading. By truth.
This is not trade. I give you.
Yeah, but yes.
I don't expect anything back.
Yeah, you say, okay, you say, the economy of gift, the economy of
That's
gift.
the moment we share.
Yeah, for sure. But this is very close to communism, you just say that.
I don't see anything wrong with that.
Well, anyway, this is a political stance, okay? So you can defend that. I am not against, but anyway, this is a political stance. I prefer to concentrate on the technical stances. But yes, this could be a possibility. In fact, as the way you are putting it, it goes beyond communism. It's more gift economy. But yes, of course it can work. Of course it can work.
This is close to a planned economy, which was the issue you were talking about before, no?
Yeah, no, but you know la economía del don?
No. This is close to a planned economy too.
A planned.
To make a
Well, planned economy is communism. Right? Well, but capitalism is very planned, actually. Yeah, well, okay. But not all the people share the same view. This is important. This is a political stance, and I do not support any political stance. I mean, I can understand, but I do not support any political stance.
Maybe change a little bit the direction of the discussion.
So please.
Thank you very much for your presentation. It's scary, but I loved it, and I took a lot of pictures. Imagine that you were not talking to this audience. Most of the people are engineers, physicists, mathematicians, and educators. But if you were talking to people like people who have the power of changing education at the basic level, okay? And also some parents at the audience, people that have small children, young children. Which kind of advice you would give to these people based on what you said to us?
Yeah. In fact, I do this a lot. Normally my audience is more like that than this one. So in particular, I explain these things in Catalan or in Spanish, not in English. Well, I think that it depends a lot on the specificities of the people that are requesting your advice. So there are some people that just want to get informed, and what I typically present to them is much scarier than the thing I have presented here. I have been content here, because I have one slide in which I made the summary of all the countries that now are in the sheet. And the problem is that this list is longer. I have already 25 countries inside, but I will need now to enlarge the list to 40, and I probably it's not going to fit into the slide. Anyway, when, for instance, sometimes I'm giving talks in high schools and primary schools even, or for instance, for association, family associations, whatever, I typically finish by making some recommendations on how to gain resiliency, because things are going to get very hot in the next months, because we're now talking about months. When I start talking about these things 12 years ago, I was talking about years. Now we are talking about months, or maybe weeks, or if we are really lucky, days. I don't know. But the things are getting very dark. And also something important. It's completely different if I'm talking to people here in Europe or in Spain, that you are talking to people, for instance, in Latin America, which is a completely different situation there. Many of the things I say, sound like a joke for them because they are much worse than that right now. So it depends on the context of your audience. So in general, my final advices are about gaining resilience. So not taking debt, trying to create a community, supporting on the community, try to make local consumption, try to reduce your expenses associated to transportation, and thinking about making changes in your career and your job expectations based on the situations that can be posed in the future. This is the kind of final recommendations in this kind of talks. But again, I am just a poor physicist. I know what I know, so I have not the answer for all the questions. I can just give some common sense recommendations, which are my personal views on that, which are not more, qualified than from anyone else.
We have talked about people in big enterprises, financial sector, but we need to talk about it. Or I would like to have your opinion because you have interact a lot with them, which is the other side of the coin, which are politicians.
Yeah.
Just your opinion. You have interacted with them.
With politicians, yes.
With politicians, I mean. So how do you see? How do you see
The situation right now.
How do they receive all this stuff, these ideas that you?
Well, I don't know if you know, I know you know, but I know if the audience knows, past year I was at the Spanish Senate explaining this kind of stuff, and it was a very enlightened moment because at that moment, which was April 2021, they were discussing a bill, a law on precisely the energy transition and so on. And I went there, invited by them, by one of the political groups, and I explained those things. I was saying, well, taking into account what could happen if next year oil becomes very, very expensive, we start to have problems with materials, we start to have problems with food. There was something, there was a trend that was very clear at that moment. I mean, for me, it's not magic. I mean, at that moment, it was already very clear what was going to happen. They are now surprised, but the things were very clear, even without the invasion of Ukraine. Now it's even worse, for sure. So from that point on, I have some contacts prior to this, but from that point on, I have much more contacts with them, and also with enterprises. So the attitude by people coming from enterprises is typically very receptive. Well, they are contacting you, so they are looking for something. Okay, they are very receptive. I think that you can establish a good dialogue. When you are contacted by administrations and even politicians, I think that the tone is fear. They are scared. And so they want to keep the contact. They want to keep to be kept informed. In fact, I am passing information to some specific people on those topics, but they find it very hard to react because it is hard to react, actually. I mean, because you need to go outside the conventional ways, and nobody is still prepared for doing that, at least in Spain. I think that in other countries things are evolving, and probably, but well, I don't know. It's complicated. I think in Europe, in general, we are not going the right way, but we'll see.
I think this discussion is really, really interesting, but I think we are forgetting one thing. Population growth. Why didn't you mention that?
Well, the population is a sensitive question because several things. First of all, because when you discuss about population growth, many times it's the kind of question, raised by a white male from a first world country. So this is the case right now, okay. And typically when we are discussing the problems associated to population, we are a lot of people. Well, if all the people from the United States and Europe disappeared, which is a minority of the people of the world, the rest of the world will probably have very good years for 40, 50 years. And they could adapt easily. So the problem is not only population, it's also the consumption per capita. And this is the key point. So normally I don't want to discuss about population because people are not typically prone to discuss about the consumption per capita. But it's the first thing to be emphasized, and especially in places like Europe and in places like the United States. If we reduce our consumption rates to the same rates as the rest of the world, the average of the rest of the world, or even I would say the highest in the rest of the world, the situation will be much easier to be tackled. Anyway, it is clear that one of the problems that we have with the food line is associated to the problem with fertilizers, especially with nitrogen fertilizers, but in the long run we are going to have also problems with phosphates and in less degree with potash. So we need to think in reliable, sustainable ways for growing food. And this implies, well, different kind of agriculture, different kind of things. Well, I think that with the knowledge that we have now, we could attain good revenues, but take into account that we at the same time are under the effects of the climate change that we have unleashed. In Spain, for instance, this year, the harvest, the cereal harvest is going to be around 40% less than a normal year, but the problem is that it's not only Spain. This has happened in India, this has happened in many other countries because we have, to my knowledge, the first year in which I have seen a really worldwide drought, okay? So we need to tackle with climate change, and this is not going to be easy. Most likely, the amount of people in the planet that can be maintained on the basis of really sustainable agriculture is an amount of population which is less than current levels. It's probably less. I don't know how much. This is a question that has been posed from time to time, but I think that probably much less. So this is an additional reason, at least from the humanitarian point of view, to take profit of the existing resources to make a slow transition to the real carrying capacity of humans that this planet has. The problem is that we all know that most likely the way in which we are going to settle this thing is by means of wars and anger. But we should try to avoid that. Yeah. Huh? Or pandemics, or everything combined.
Short question. Don't you think there is a lack of education in the engineering degrees, architecture, lawyers, economists about all the environmental things, basic biology, ecology, basic
System, yeah.
systems, ecosystems, ocean, the influence of the ocean in the atmosphere, stability. So you're talking about problems that other experts in other fields don't know anything about that. So
I think that is a serious issue with university curricula for sure, and combines. This affects also hardcore science matters. Right? I think that there is also a problem with physics, with chemistry, with biology. I mean, it's a problem which affects all disciplines, all of them. But normally when you have received training in for instance, in mathematics or physics or chemistry or biology or whatever, you are typically well trained in critical reasoning and problem solving. So it's quite easy that you can do the path yourself. But not all the people do. And that's something that we were discussing with Thomas previously. No? For instance, many of our colleagues, knowing about these things, they prefer to look around, not trying to look in that direction because it is quite uncomfortable. The position that we have is quite uncomfortable. Because this implies, for instance, I am here now today, the other day I'm going to be in another place explaining the things. I would like to look to see other people like me that know the things as well as me or even better, explaining the same things. But if you are doing this, you are really complicating your life. You are really getting into trouble. And this is stupid, but it's the way we are doing things. Also because we know that once you go a bit farther away in analyzing the progress, you end up by criticizing capitalism. And this is not fancy. This, you don't pick up a lot of people doing that, okay? So this is hard, and this is a problem. And when you go, for the teaching of humanities and so on, the problem is even worse, because many times, and it happens to me, for instance, discussing with politicians, if they come, which is the usual case, they come from law, or they come from economics, even worse, they really struggle to understand what you say. And I was commenting previously, when you're discussing with people coming from law, I say, well, we should try to do this, and you say, well, I think that the second law of thermodynamics doesn't allow it. But we can try to negotiate. Negotiate with the second law of thermodynamics. No, I think you have not understood the thing. So, and this is a problem. So, but this, I think, is something which is quite general. I think that natural sciences have an image of being too hard, I don't know. There is a part of society that leaves behind them, and that is very bad, especially in a so technified society as we have right now, because our society is technically very complex, actually. People don't understand how electricity is generated. And I listen a lot of things, very misled things, I mean, by good faith, but very misled. Just because people don't understand what electricity is. And we have these problems in every aspect of the life. So maybe we should try to improve what we consider the basic curricula at the level of high school, maybe, or anyway, the compulsory education, and trying to improve other things, and also, explain what sustainability is, because many people doesn't know what sustainability is, and this is something that cannot be acceptable in a finite planet as we have. Well, probably we need to finish, but...
No, I need to say something,
So please go ahead.
That your concern, it's too late. We really need to start not when the student decided that he's going to be an economist or an engineer or, because we need to start when they are really young children,
Yeah.
giving them scientific and technological literacy. Because otherwise, are we going to expect the guy or the girl to be, 17, 18 years old to talk to them? Look, let's start talking about, how all this stuff is going to impact your life or your children. It's too late. We need to start at kindergarten, Otherwise,
I absolutely agree, and I have some experience on that. The times I have went to primary schools to explain these kind of subjects, for sure, I have a much more simplified and less scary presentation for them. Yeah? Okay, but they are children at the end. So, but when you put the things in very simple terms, and they understand very well, and they are very eager to learn, to listen to what you're saying. For me, the main gap is at high school. When they arrive at high school, because I have given a lot of talks at high school, and you go there and people say, well, this is a science thing. And no, this is not a science thing. I'm talking about your fucking life, excuse me. But this is true. I'm talking about how your life is going to be. So you should be paying attention. The last time I went to high school, I went to my daughter's high school. And it was absolutely impressive. Only the people that think about doing science bachelor, they were really paying attention. They was, well, this is a scientific thing. It's a scientific thing.
Yeah, but the problem is that in some way
in the past, from primary to high, yeah.
We lose them. We make them hate math.
I'm going to explain you why.
Yeah, they are born with the tablet and the little chicken, little pig. I don't know what's the name of the thing, and they don't know three-dimensionality. I was building towers with 6-year-old kids, and they were building two-dimension towers. Because the life is flat.
They should play Minecraft as my kid. But anyway, yeah, I think that there is a problem associated to this, but also I think it's a problem associated to the way in which science is understood by society, this also starts with the parents. In general, science is something, the scientists in some sense are like the mechanics. This is the guy to which you bring your car to get it repaired, but you don't care. And you don't want to listen too much about what he's saying. This is boring. So, and this is not boring, this is your life. And this is critical to you because you need to take a lot of decisions based on what is happening. And you need to understand what is happening because, in fact, if you don't understand what is happening, probably you are going to think that maybe climate change is a hoax, like some people think, or the question is that the oil companies are taking a lot of profit of this situation. In fact, they are, but the problem is deeper than that. And and they are going to go around with simplified statements, and at the end, you find that one day there is a crowd trying to invade the capital. This is the kind of things that happen. So we need to explain, yes, people need to understand science, and something which is important, these kind of things are so critical that needs to be explained, it needs to be repeated. We need to explain this to the people and contrast the data. Some people say, you are two catastrophes, I don't know. Well, if one of my data are wrong, and in fact I'm using data from the International Energy Agency, the Department of Energy of the United States, the main consultancy in the world, if you see something which is wrong, please keep me informed, let me know what. But if you don't have arguments, I don't need your patronizing, okay? So the key point here is well, let's discuss this. Because the situation now is so serious that we cannot afford to lose more time. And as I have said, I have just sketched here things that can be done from the engineering point of view. I am a physicist, I'm not an engineer. But there are several things, I have been thinking about that, and I think that can be useful for you. But probably there are many, many other things that you can think about. And in fact, for instance, the curricula should be oriented to that. When you are educating new engineers, are you going to tell them, well, you are going to have this chip coming from China at that price, and maybe you're not going to have it. Okay, so you're going to use this, numerical programming machine for the mechanization of a piece or whatever. But what happens if you have not? Maybe you have to do the old way. And you need to forge metals the old way. I don't know. So the question is, what kind of engineering could the next generation, but not the next generation, the next generation going to be able to do? And this is the thing that we need to discuss. For instance, where are we going to obtain high quality materials? Do you know where we're going to, here in Europe, in Spain, where are we going to get the next batch of high quality materials? From the dumps. This is the place that we are going to have this. And also when we are going to scrap, for instance, the traffic lights, something like that we're not going to need anymore. This is where we're going to obtain good materials. And this is the kind of things that we need to think about now.
From where?
Okay.
The waste.
Yeah, the waste, yeah, the dumps, the dump. And this is the kind of things that we need to think about. And this is the kind of things that we need to discuss about. Because otherwise, we're expecting that everything is going to be short magically, automatically. I think it's not that way. We could collapse. Collapse is an option. It has been always an option. We know about 26 civilizations before ours that has collapsed, in some cases to the total extinction. So if we collapse, we will be just the 27th, which is not a very glorious position, actually. It's not the pole position of collapsing. So collapse is always a possibility, but taking into account that collapse, in fact, is always a decision. The societies that collapse because they have decided to collapse, because they have get stuck in an idea which is a wrong idea. And in our case, the wrong idea in which we are stuck is that we think that we can grow forever in a finite planet. This is our wrong idea. Well, it's the same thing expressed in different terms. Okay, I think that we are really well ahead.
We're a bit late. We still have stuff to do, so if you think we're going to have a 5 minutes break, just to
digest.
recover ourselves. And in 5 minutes we'll meet here, and I will give you some information and some instructions for the challenge. Okay, so thank you very much.